Hello students, welcome back to Organic Embers YouTube channel. In this video, I'm going to explain nucleophilic substitution reaction and the stereochemistry of the products using an example. What is the question here is, which among the following can yield the more stereochemically pure product? First, let's understand what is more stereochemically product means. A stereochemically pure product is a compound that consists of only one specific stereoisomer, meaning its molecules have the same three-dimensional arrangement. It is usually not a mixture of stereoisomers. It is composed of just one product. Now that we have understood stereochemically pure product, let's analyze the reactions given. All the given reactions are nucleophilic substitution reaction. You know that in a nucleophilic substitution reaction, nucleophile displaces. It substitutes a living group and forms the product. This can happen through SN1 or SN2 mechanism. By now, you must know what is SN1, SN2 and what happens to the stereochemistry of the products if the reaction is happening at the chiral carbon. If you don't know, anyway, I am going to explain with example here. In SN1, if the reaction is happening at the chiral carbon, we know that we are going to get enantiomers, mixture of products. That means what? It is not stereochemically pure, right? If it is SN2, there is an inversion of configuration, right? Then it can be stereochemically pure product. Let's analyze the first reaction. You see here, it's a tertiary halide. This is a tertiary halide because this carbon is attached to 3 carbons. And it is methanolysis. What is methanolysis? The reagent is taken. Here is methoxide, right? The solvent itself is acting as a nucleophile. So it's called methanolysis, right? So when it attacks the chiral carbon, right? So here it is undergoing SN1 as it is tertiary halide, and you will end up with the enantiomers. So this is not A. The right option is not A. Let's check for B. For B, you see here the halogen is attached to a primary carbon and it does have a chiral carbon here. This is the chiral carbon. Why so? Because it is attached to different groups. And it is treated with sodium methoxide in methanol solvent. So again our nucleophile is methoxide. And it will undergo SN2 because it is primary. And you are going to get a product like this, right? The methyl is here and the hydrogen is below the plane. This will be a pure product. This is the only product formed here because the first reason is it is undergoing SN2. It is one step. It attacks, it leaves the molecule. The second reason is the reaction is not happening at the chiral carbon. It is intact. Therefore, we are going to get only one product, only one enantiomer. So the right option is option B. Let's check if we have one more right option. Let's check for option C. Look at this carbon, it is attached to 2-methyl. So there is no possibility of chiral carbon itself. And this will, however, will undergo SN1 reaction. So either way, this is not the right answer. Let's check for this. Yeah, this looks like a chiral carbon, but both of them are attached to methyl, not possible. However, this carbon is chiral because it is attached to 4 different groups. But because this carbon is secondary, we might end up with the major minor products or maybe enantiomers. Therefore, this is also not the right option. So among the 4 given reactions, reaction which gives a stereochemically pure product is option B. Therefore, the right option is B. Thank you for watching this video, and if you have any doubts or any questions, you can always post them in the comment section. Thank you.